Howdy y'all, back for another video. Today we're going to learn about distance, rate, and time. This is going to be section 8.3.2 in your book. And as we go through the lesson today, I want you to kind of pay attention to the pictures, because the pictures are all kind of related to this lesson. And specifically kind of be thinking about these things in relation to bike riding, for example. Distance, that can refer to how far did I ride my bike, right? The rate would be how fast was I riding, and the time, of course, would be for how long did I ride my bike. So we'll go through a few slides here. So let's start off with giving you a formula for distance. Distance is equal to rate times time, okay? So for example, if I was trying to solve for the distance of how far did how far did I drive my car? If I knew these two things, I could be able to calculate the distance. So for example, if I was driving at 25 miles per hour and I drove for 4 hours, I would basically do 25 times 4, which equals 100, which means my distance would have been 100 miles, okay? What I want you to also know about this formula is you can tweak it to solve for any one of these three items, okay? As long as you have two of those three, you can solve for the other one. So I just want to make sure that you're aware that you can flip this formula around. One way to do that is to do the following. Say I want to solve for time, okay? That means I need to get the times, or the t, all by itself, okay? So in order to do that, I'm going to do the inverse operation of what's happening here. So remember, when you have two variables next to each other like this, it means they are multiplying. So the inverse of multiplication is division. So I'm going to divide by r. Now if I divide by r, these two essentially cancel out, because r divided by r, it's basically 1, right? If something is divided by itself, it becomes 1. 1 times t is not going to change anything, so the t will still be solid all by itself. The only thing I have to do is, if I divide on this side of the equal sign by r, I also have to do the same thing on that side of the equal sign. So I'm going to do d divided by r. So now my formula is t is equal to d divided by r. Okay, so if I go on to the next slide. So I just did that backwards. It's the same concept though. This one is the formula for rate. And essentially all I did was I divided by t to get the rate, the r by itself. And once I did that, I have the formula of distance divided by time is equal to my rate. Okay? And then, so think about a horse, for example. If I want to know how fast the horse was running, I could take the distance he ran, divide it by how long he was running, and that'll tell me the rate at which the horse was running. Okay, and then here's your last one. If I wanted to solve for time, I'm going to divide distance by the rate. So an airplane, if I want to know how long it would take me to, if I'm traveling to, Florida, and I know how many miles that is, I can divide that by the average speed of the plane, which you could probably find that online too. Divide the distance by the speed or the rate, and you will be given the time of how long it'll take you to fly to Florida. Okay, so pretty useful formula. If you're planning trips or things like that, it's something you could use to help you do that. All right, so I want to give you an example and kind of work through a real world example. Let me grab my friend here. Come on, buddy, come on. Y'all remember Caesar, right? Hey, Caesar, good boy. So Caesar and I have been training, and Caesar is planning to run not a marathon. What's he running? Oh, he's just doing a race at the county fair. He's been preparing for that. Right, dude? Yeah. So anyway, I've kind of been working him hard, and I've been timing him with my stopwatch and everything. And I've come to the conclusion that Caesar can run at a rate of 11 feet per second. Okay? 11 feet per second. Also, I failed to mention, he's excited about this because the winner gets a year's supply of bananas. So he's thrilled about that. So let's go ahead and write down what we know here, okay? If we know that Caesar can run at 11 feet per second, that is a rate. So let's write that down. Rate is equal to 11 feet per second. Okay, so there's my rate. Now, in Caesar's training, well, actually pause for a second. If I know that Caesar can run 11 feet in 1 second, how far can he run in 3 seconds? Well, that's pretty easy, right? All I have to do is multiply this by 3, and so now I know in 3 seconds, Caesar would run 33 feet. In 5 seconds, how far would he run? 55 feet. 11 times 5 is 55. And say he ran for 60 seconds, for a full minute. How much distance would he cover? Well, 60 times 11 gives me 660 feet. Okay? So that's pretty easy. Now, let's say that Caesar's racetrack, so the distance of the race that he's going to run is 150 feet. All right? Let's add that to our what we know up here. Okay? So distance equals 150 feet. All right, so now I just need one more element, and that's the time, right? So that's the question here that we're trying to solve. It says if the racetrack is 150 feet long, how many seconds will it take Caesar to finish the race? Okay, so that's time, right? Seconds. So if I write time right here, and I don't know what that is, right? That's what I'm trying to solve for. Okay, so what we can do now is we can take our initial formula that we've committed to memory now, right? That's a good one to memorize. Distance is equal to rate times time. Okay? I'm trying to solve for time. That's the unknown that I need to figure out. So that means I want to get the t all by itself. Okay? So rate times time. The opposite of multiplication is division. Again, I'm going to divide by rate to cancel that out, which means I have to divide by rate on this side as well. Okay? So now we can just simply fill in the blanks. Let's fill in what we know into our expression, and then we can solve. So I'm just going to write it, flip the equation around. So it says time is equal to distance divided by rate. So time equals distance of 150 divided by the rate of 11 feet per second. All right, so now if I do 150 divided by 11, I guess I got to do a little bit of long division here, sorry. 150 divided by 11. Okay, and I've got a repeating decimal. So it comes out to 13.63, and that's repeating. So that means that Caesar would have run 150 feet in 13.63 seconds. Okay? And there's my answer. So there's my time element. That's basically distance, rate, and time in a nutshell. I say that a lot, I think, in a nutshell. I don't know why I say that. But anyway, this is going to be your homework for today. This will be, Wednesday's homework? I'm making this on Tuesday, so Wednesday's homework. What I want you to do is just make up your own question involving distance, rate, and time, be creative, right? Make it fun. And then solve it. Okay, so create an equation using distance, rate, and time. Write it out as like a word problem, and then solve it for me. Okay, you can do that on, I'll leave the text entry tool open. I'll also leave file upload open. So if you want to do it on paper and then upload your file, you can do that. If you'd rather just type it into text entry, you can do that. Clear? All right, enjoy, guys. Hope you enjoyed getting to see Caesar. He misses you guys. Say bye. All right, be good, guys. See you later.